All right. Morning. I'm going to try to do 3 things today. We're going to see how much of what's left on here on these. You can turn this over on the back because we're up to the back. So we're going to do at least a few of these. We're also going to go over Chapter 3 in the book. Chapter 3 is a very different chapter in that I might have even made Chapter 3 Chapter 1. But what the author tries to do is explain a lot of concepts that are explained throughout the book. There's nothing wrong with doing that, except it's really easy to get you confused. All right? So if you did read through it, you were confused, don't worry about it, okay? Because we will talk about it, but you're not, what you have to know about that right now is not that important. Now, if you have your piece of paper with you, I'd like you to make a change on it for me, please. That is, for number 5, where it says 6420, all right, where it says 6420, I'd like you to cross that out, do whatever, change it to 11,828, and then where it says 3 hours, 17 minutes, and 0 seconds, make it 3 hours, 17 minutes, and 8 seconds. And if you say, well, why are we doing that? That's what this program is about. So if you still have the question at the end of the program, then let me know. Yes. Well, you can have this one. Everybody got one yesterday.
Oh, never mind. Yeah, right here.
The one with the stop sign on the front. Okay. All right, so you've made that change. Let's start up Visual Studio then, if you don't have it started up already. All right, and again, we will create this first as a console, then as a GUI. Then you're going to find that the next program is very, very, very similar to this one. We'll do that as a console, then a GUI, and then we'll see where we are time-wise. We're going to sneak breaks and stuff in there too. It's not like I'm just going to keep going. I think the people yesterday, because I told them we're finishing this program, and I don't care how long it takes. So usually they get a break after 50 minutes, 55. It was an hour and 10 minutes, and they were like all sitting there. 2 or 3 people just got up like, I got to go to the bathroom. If you got to go to the bathroom, go. All right. I remember my 7th grade teacher, Mr. Hagee, telling the story of he had just bought himself a brand new suit. It was cream colored. He was so proud. He said, man, I look good in it. First day a woman comes up and she goes, Mr. Hagee, I got to go to the bathroom. I'm really... And she puked all over his brand new suit. And he said, so my rule is, I don't care what the school says. You got to go to the bathroom, especially if you're sick. Go. So that was the first day of class. That's the first thing he told us. And not to that extreme, but you need to leave for a minute or two. Fine, you need to leave. All right? Okay, so as we've been doing, I'm going to come in here and I'm going to create a new project. And again, as we've been doing, I want this to be a console app for the .NET framework. All right? I've told you 2 different ways you can check for that. It might be here in your listing already, or you can type in console app up here in the search bar. Make sure that's highlighted. You can see that it's in blue, and click next. All right. We are told that this one we want to call hours, minutes, seconds console. Again, save this where you would typically save. For me, it's the desktop, and again, I am keeping the project name and the solution name the same. All right? So once you've done all that, just please click Create. And that's going to get us started. This, again, is what we, for lack of better words, kind of like a standard beginning right here. We've talked about this before. Also, I'm going to add a new line 6 in there in just a second. You've seen me do this for every console program. I'm going to type in using static all in lowercase, system.console. You know why we're doing that, because we've mentioned that before. All right, so using static system. Notice as soon as I type in system and I put a dot in there, it brings up the IntelliSense. So it knows if I put a C in there, wow, a CO, you can see how it's going down as far, and there's console. Okay? Make sure you put a semicolon at the end. All right. Now, I put this up on the board mainly for my own edification, but I'm going to show it to you also. I think everybody, what I'm about to say, you'll agree with this. Okay? There are 60 seconds in a minute. There are 60 minutes in an hour. I think everybody'd agree with that. So if I did my math right, that should mean 60 times 60. There are 3,600 seconds in an hour. Okay? Who cares? Okay, we're going to need all that stuff as we go in here. Now we've got our choice. We can just use the number 3,600. We can use the number 60 in both cases. We can do that. Or we can make constants. What I'm trying to explain to you is part of the reason you might want to use a constant is it'll make the program more readable. Now, you could turn around and this isn't going to change. They're not going to all of a sudden make a minute be 70 seconds. So why don't we just leave the numbers? I understand that. So you could do that. But actually, if you know something that's not going to change, you know it's not going to change. Inches in a foot. All right, type of thing. All right, you just know it's not going to, sometimes that's a really good reason to make it a constant. All right, because you know it's not going to change. But again, it'll make your program more readable. So I'm just going to grab these. You don't have to do it like the way I'm doing it, but you're going to see it just a second. Now, I'm going to paste this in. It's going to give me errors because it thinks I'm trying to put code in here. It doesn't know what I'm trying to do. Okay? So I'm going to come in and I'm going to create three constants. I'm going to say const int, and I'm going to call it seconds in a minute, and I'm going to set it equal to 60. So there's my first one. Yes. And here's will be my second one, const int minutes in an hour, and I'm going to also make that 60. All right, whoops. And then finally, const int, what's wrong with me today? Seconds in an hour, and I'm going to set that equal to 3,600. All right, so that's how I'm starting this program out. Now, a couple things here. You'll notice I've got two constants here that have the same value. Could I have given it a more generic name? All right, and used just two constants? Yes. All right. And did I go overboard here? In what I'm saying is, do we really need all these? You could argue and say no. It's totally fine. Okay. The other thing that it says in here is we're supposed to declare a seconds value between 1 and 86,400. That's what's written on here, right? Okay. So I'm going to create two additional constants. It doesn't matter if you may do them first or if you do them last, whatever you want to do. So I'm going to say const int, and I'm going to call this min seconds, and I'm going to set it equal to 1. And I'm going to have another const int that I'm going to call max seconds, and I'm going to set that equal to 86,400. All right, that is the number of seconds that are in a day if I did my math right. It's not that big a thing. But one of the things I'm going to want to do is after I read in a value, I'm going to want to check it to make sure that value is between 1 and 8,600 or 86,400. If it doesn't fall within that range, I'm going to give the user a polite error message and ask them to do it again. Does that make sense? All right. And it's going to allow me to show you something while we're doing this. So to start with, and we've been doing this kind of stuff before, we'll put a write statement in here, and we'll say, please enter number of seconds. All right, and I'm going to even try to be nice to the end user, and I'm going to give them a message that lets them know what they should put in there as far as the number goes. Does that make sense? All right, I'm going to let them know. And then I'm going to say, we're going to create we have to create a variable too that's going to hold our seconds. In fact, think about what kind of variables are we going to want in here. We're going to have one that's going to hold our seconds, one that's going to hold our minutes, and one that's going to hold our hours. Does that make sense to everybody? Because if you look here on this handout that I gave you, we eventually want to print out like 3 hours, 17 minutes, 8 seconds. So we'll need a value for each one of those. These are constants. You don't have to put this in there, but they're constants, just so you know. Their value cannot change while the program is running. On the other hand, these three will be variables. They can change. So it'll be int hours, and we'll just set it equal to 0, so it's got an initial value. Int minutes, and we'll set that equal to 0. Int seconds, whoops, wrong, and we'll set that equal to 0. All right, so we now have 5 constants and 3 variables. Okay? All right. Now, right now, I'm telling you to read in the number of seconds, correct? Isn't that what the message says? Okay? And I can put that into here. But I want to be manipulating this value. These 3 values are going to change. Would you agree? At least they could all change. All right? They may not all change. I mean, if I put 1 in there for 1 second, hours will still be 0, minutes will still be 0, seconds will now change to 1. But conceivably, all of them could change. So I'm just going to add one more variable in here, one more integer, and I'm going to call that tot seconds. If you don't like the word tot, you can call it total. It doesn't matter, but that's what that represents. I'm going to move this down. I'm taking for granted everyone who wanted to put in these 5 constants, put them in. All right, so I'm going to go down to here. So my total seconds is equal to convert dot to int 32. We'll talk about what that means in just a minute. Read line. Now remember, at the very bottom when we run this, we'll need another read line. Otherwise, it's just going to disappear. It's going to blip off the page, right? So I'm going to save this and run it just to show you what we have so far, which isn't much. But I'm going to run it to make sure I don't have any errors. So it should come up on the screen and say, please enter number of seconds. That's a good start, right? That's what we wanted it to say. We're not doing any checking right now. I can leave it blank. I can say hello. I can do a bunch of stuff, and it'll break. But let's just say I'm going to just put in here 1, 2, 3, 4, 5, just so got something in there. Boom. Now it's waiting for me. Does that all make sense? All right. We haven't done any calculations yet. Nothing. All right. So we have to start doing some calculations. Now I'm going to show you. Don't type this in. I'm going to show you the wrong way to do this. Did you all hear me? I'm going to show you the wrong way to validate this. Don't type this in, because I'm going to show you why it's wrong in just a minute. All right? So I'm going to come in here. Again, this is wrong. I'm going to say if the total seconds, all right, if it's less than our minimum, which we called min seconds, okay, so if it's less than that, or, and don't worry, I'm going to explain these symbols and stuff to you in just a minute, or our total seconds is greater than our maximum seconds, we want to write, we'll do a right line here. Again, I'm going to show you all this stuff. I'm going to run it for you. Then I'm going to break it on purpose. All right? So I'm going to put in here error out of range input re-enter. Now you can be as nice about this as you want to be. In other words, I've had people say to me, you didn't put please there. No, I didn't. Partially because I don't have all that much room on here. But if you want to say please re-enter, then say that. That's totally fine. What you don't want to do as a programmer is put something insulting down. It's like, idiot, didn't you read the instructions? You just don't do that. All right? Yes. I had one. Now, if I say this word and I'm offending anybody, I'll apologize first. He loved to use the word dickweed. And he would put error messages that would say, error, dickweed. He would just do that. He did it until he turned in his first assignment and he got a 0. Even though everything worked. And I said, I took off 10 points every time you used that. And he said, well, how do I get them back? I said, don't do that again. And he didn't. So, all right. But all I'm going to do then is I'm going to ask them to do it again. Okay? So, let me save this. Let me run this and show it to you. All right, I'm purposely going to run it a couple times, and I'm going to put in numbers that are out of range. Did you hear me? So I'm going to put in a negative number, -4. I think you'd agree it's not in range. Hey, look, it worked. So it said, out of range input, please re-enter. Please enter the number of seconds. I'm going to put in -4 again. Guess what? Now it took it. When you try to validate like this, and you use an if, it only checks it one time. So it's like I ask you your name. I ask Angie your name, and she's just in a weird mood, and she said, Helen. And I said, what's your name? Are you sure? And she says, Helen. Well, then I got, the way this is set up, I've got to think that's her name. But if I change this from the word if to the word while, watch what happens. So I come in here. I might have to play with the spacing because this is all going to look crunched together, but -4, put it in again, -4, see that? Now I'm stuck there. If I put in 86,000, 86,401, still out of range. But if I put in 86,400, now it takes it. Do you understand the difference between those two? So when you are starting to validate, like we're doing here, all right, you want to use a while or something that will keep them constrained in that area of code until they do what you want them to do. So in other words, I can tell you with 100% certainty, by the time I get down to this line, I have put in a value between 1 and 86,400. Because if I didn't, I'm going to be stuck in that loop. Now, if I want it to look a little bit nicer here, for example, I can put in here, like a \n, oops, and I lost my double quote. So I could put that in there if I wanted to. All right. So it'll say that, error, etc. And then it'll tell you to do, let's see, please enter. Okay, so it'll say enter. Let's see, error, do it again. I'm not sure if this will look better or not, but I think at least you get the idea. So I'm going to put in something out of range here. 1, 2, 3, 4, 5, 6. See, so I've done a little bit of work there with the spacing. You might like that better. You might not like that better. If that's too much space, just put in 1 \n. But it's kind of nice to separate it when you crunch everything together. It can make it hard for the person looking at your program to read it. That's all. And one of the things you want to strive for is you want to make sure that who's ever running the program, first of all, they know what it is that you want them to do. You give them instructions that make sense. All right? But the program should always do what you want it to do. All right? Now, one thing is, and I've mentioned this to you before, but just so you hear it, my afternoon class, it's an Android programming class. We're doing Android programming in Java. They've already written, yesterday they wrote they've written over 1,000 lines, I think, in 2 days. All right, why? Because I'm trying to teach them just the Java part. There are certain ways that you do things, and sometimes as we go through this, you may look at those, why are we doing it this way? It's because, to me, it's the most intuitive way, and it's the best way to teach you something. And they're going through the same thing in there. I'm going through some stuff with them. A guy asked yesterday, why do we do it like this? And I gave him the answer, and I could tell it was like, okay, I understand what you're saying, but I don't agree with it. That's fair. Well, I understand that. I'm not saying you have to agree with it. I'm just telling you that's the way that it is. All right. So would everybody agree that by the time we get down here, we have a valid input? Would you agree with that? All right. Well, one more thing, and again, these two have heard this last semester. See this thing right here? It's a pipe sign and a pipe sign. It's right up above your enter key. Shift and then right up above your enter key. Two of those means the word or. That means if either one of these conditions is true, you will go in here and you will do this. So if either I put in a number less than 1 or I put in a number greater than 86,400, does that make sense? What we're starting to do then is we're starting to do some input validation. All right? The other thing too is, just like we've done a little bit of work where we looked at an if statement, okay? But these are Boolean conditions also. Boolean is true, false. Either that's true or that's false. Either that's true or that's false. All right? When you use an or like this, if either one is true or if they're both true, then the whole thing is true. Did you hear what I said? Okay. What if I didn't want to do it this way? Now, don't change your code. Don't change your code, but I'm going to copy this. And again, I'm going to remove this in just a minute. I could have said, while the total seconds is greater than or equal to this, and, which is 2 ampersands, the total seconds is less than or equal to. The difference here is this is valid. So here I'm checking for invalid. Here I'd be checking to make sure it's valid. This is or, this is and. With an and, they must both be true. So this says, if the number I read in is greater than or equal to 1, and the number I read in is less than or equal to 86,400. Do you understand the difference? Because you're going to see this. And if you're like, well, I sort of do, that's good. You know, I'm not going to go out there and expect you to be able to just do it like that. But this is an opportunity to show you some of this stuff that are kind of hallmarks of any programming language. All right? So here I'm writing it basically as an or. Here I'm writing it as an and. With an and, again, they must both be true. And you two may have heard this example already. I don't know. But imagine it's like this. Let's look at this one first. So I decide, I'm not going to, but let's just pretend. I decide I'm going to have a party. And in order to come to the party, you have to meet 2 criteria. You have to be a student in the AWD Application and Website Development Program, and you have to be of legal age. So you have to be 21 because there'll be alcohol served there. Does that make sense? That's kind of what we have here. Both those must be true because it's an and. If either you're not in the program or you don't meet the age requirement, you can't come. Period. So I do that, and I buy enough food for about 50 people, and then I realize, you know what, there's only 5 people in the program. we're probably not going to be able to eat all that food. So I change it from saying that you have to be a student and you have to be legal age to an or. So I change the and to an or. That means if you're in the program, you can come. That also means if you're greater than or equal to 21, you can come. Some of those people who come may meet both criteria. So when you've got an or, only one thing has to be true for the whole thing to be true. When you've got an and, every part of this has to be true or the whole thing's false. Some books will say they're kind of opposites of one another. They pretty much are, but not exactly. All right? We'll meet up with another one in a bit that's called not. Not's an inverter. Single is the same as not married. Would you agree with that? Married is the same as not single. All right? If you're not a member of a union, you're not union type of thing. All right? So it's called an inverter. So I'm going to get rid of this for now. I just wanted to show that to you. So once I get down to here, we have entered a number between 1 and 86,400. We've done it. Now, we're not done with the program yet, but we've done that. All right? So let's pretend we've inputted the number, the right number now that's on here. What did I say? I think it's 11,828. All right? So when we do 11,828, we want that to pop up. We want this to pop up. How do we get that? All right. Well, we've got variables here that are called hours, minutes, and seconds. You can all see that. Okay. Oops. That's from this morning. Sorry about that. So what I want to do is I want to take that number, 11,828, and I want to divide it by, okay, I want to divide it by the number of seconds in an hour, 3,600. And I put a 3 in there. And what does that give me? 10800. So I'm going to have left 1028. Does that make sense? All right. This is our number of hours. I'm not asking you that. I'm telling you that. That's our number of hours. So, since I know I have a valid number, now I can start to figure this out. So my hours is equal to my total seconds divided by, what did we call this? Seconds in an hour. Okay? Now, if I'm not going to do it now, but if I printed it out, it would say 3 hours. I'm just telling you that. It would say that. All right? Now, what's this? What do we call that typically if we're doing a math operation? It's a remainder. Okay? But would you agree that now we've used up 10,800 of these seconds, and this is what we have left? Would everybody agree with that? All right. So the total seconds, which was this, we want to make it this. So I'm going to set that equal to what? I'm going to set that equal to, instead of dividing, I'm going to say total seconds, and I'm going to put it on the code in just a minute, modulo, whatever we call this, seconds in a, so I'm just going to copy this line right here. So our total seconds is equal to our total seconds modulo. It's the remainder. Now, if it helps, I'll line this up like little soldiers there. Maybe that makes it easier for you to see what's going on. I don't know. So this is going to give me 3. If you look on the screen, this is going to give me 1,028. Now, I'm just going to put comments here. Why? Because I'm a brand new programmer, and I want to make sure I remember this stuff. Okay? Total hours. Total seconds. I'm going to say left. Maybe that's not the greatest comment, but it's fine. All right? Now I've got 1,028. Are you with me? I've got 1,028. Now I've got this. All right, so with that 1,028, I'm going to have to do another divide on that. So far, I've got this part done. Okay? And I've got my hours. So now I've got my minutes. So I'm going to take this, and I'm going to divide that by 60. All right? Because that's how many seconds are in a minute. So what is that? 61, 60. Make that a little easier. 60. There we go. So that'll be what? 48. Let's see, 600. 428. Which is right. 60. Once in there once. 60. 102 minus 60 is, 420. All right. So 60 times 7 is 420 with 8 seconds left. You agree with my math? All right. So it says we have entered a valid number. We have. I'm going to break this up into 3 areas. I'm going to say calculate total hours. All right, so we've done that. Now I'm going to say calculate, not even total hours. Let's just say calculate hours. That's good. Now we're going to calculate the minutes. We're going to do the same thing we just did here. But it's going to be seconds. Whoops. Seconds equals the total seconds divided by seconds in a minute. And total seconds will be total seconds modulo seconds in a minute. So this is total seconds. And this again is total seconds left. So now we have figured out the 3 and we have figured out the 17. And guess what? We also have figured out that because that's what's left. So I can now come in here and say, oh, did I make a mistake? Catch me when I make a mistake, please. This is minutes. Please change yours. They will tell you I make more than my share of mistakes. That's minutes. Change that line. Now there's not a calculation. Okay, it's just seconds. In fact, I don't even need to say this. Total seconds anymore. I can say seconds equal. Here we go. Try to make this as small as possible so that we can all look at it and say, oh, that makes sense. All right. Now I'm going to do a right line, take it for a spin, so to speak, to see if it works. Total seconds inputted was plus well, I don't have total seconds anymore. I won't even put that in there. We can put that in, but we'll put it in. Don't worry about it. Total seconds dot toString. You learned about that yesterday. All right, so that's the total seconds. Right line, total hours plus hours dot toString. I'm going to leave this here because there's going to be a mistake in my output. And that's good. I want to be able to show you that. total minutes plus minutes dot toString, and finally okay, and again I'll come right back to this, but I want to see if it gives us the right answer. Okay, everybody with me? I just want to see if it's going to give me the right answer. So I'm going to run this. I'm coming right back to the program. All right. So how many seconds? We said what?
Whatever it was.
11,828. All right. Notice 3 hours, 17 minutes, 8 seconds. So we have the right output, except for one thing, and that's this. See this? That's the seconds that were left. So actually we printed that too late. So I want to take my total seconds line and I want to move it up to right after I put in the total number of seconds. So I'm going to put it right here. Now, I went through a boatload of stuff, so I'm just going to print it out for you so you can take a look at it. All right? It's not much. It's 50-some lines. But I'm going to make a copy or print out a copy of this for everybody. Now the problem is there's a problem with that printer and I can't connect to that printer. So I've got to print it to our office printer until Chad comes in here and fixes my machine a little later this morning. So we'll just set that to the default. Apologize for that. So I'm going to have to walk into the other room for literally just a second. And I'll print out a copy for everybody. But until then, I'll leave it right here. Now, it looks like I'm not using minutes in an hour. So I'll have to look at that. There could be something in here where I could have rewritten it or written it better or whatever. But I'm going to print this out. I'm printing it out. I'm going to go grab it and give everybody a copy. And what you're doing may or may not make a lot of sense to you. All right? And if it doesn't totally make sense, especially if you're new this semester, that's to be expected. All right? That's why you're not turning this in. This is meant, for lack of better words, to just be a learning experience for all of you. Just to show you the kind of things that we are going to be working on and with for the semester. That's all. So I'm going to take this from the top, spend 5 to 10 minutes explaining it, then we're going to take a break. All right? So taking it from the top, we added this line. We added this line so we can do the console or the read line or the write line. Yes. Yes. I hope I am. Yep. All right. So you know that we add this so we can put in the read line and the write line without having to say system.console.readline system or whatever. All right, fine. So we're into here. We're in main. It is pretty much a standard, whether it's a written standard or an unwritten standard, that you put your constants on top and then you put your variables below them. Do you have to do that? No. I mean, there are no C# police that make sure you do that. But it's just kind of a standard way that most people do things. That's all. All right. Now we're putting everything in main because all we have in here is a main. What we will eventually do is, rather than having main have all the code in it, main will become what's called a driver. A driver's, if you ever had a really good supervisor and she or he, sometimes you might even think to yourself, what do they do? Well, one of their qualities is they know the right person for the right job, so they can delegate authority correctly. And that's what we're going to have main do. Main is going to call routines that are going to do the work for us. We could have taken main, we could have had one routine that just figured out how many hours there were, another routine that just figured out how many minutes there were, another routine that just figured out how many seconds there were, and another routine that printed everything out. Plus, we could have had another routine that inputted our stuff. So we could have broke this into 5 routines. You might look at that and go, well, there's only like 50 lines. Isn't that stupid? No. That's very smart. If you've got a 500-line program, imagine the difference between having 10 different routines, each of which has 50 lines, and 50 different routines, each of which has 10 lines. If you've got a problem, I'd rather have the one with 50 routines, because I can go right to that routine where I know that problem is happening. What we're doing right now is we're taking and putting all 500 lines in the same routine. You wouldn't typically do that, but when you start out, of course you do. All right? So these are our constants. There are 60 seconds in a minute. There are 60 minutes in an hour. There are 3,600 seconds in an hour. All right? The minimum number of seconds we're going to have is 1. The maximum number of seconds that we're going to have is 86,400. Okay? I'm asking you, does all that make sense? All those values do make sense? Good. Then these are our variables. Variables are called variables because what that means is their value may vary as the program runs. This starts out as 0, and you saw how it changed to 3. This started out as 0 and it changed to 17. This started out as 0 and it changed to 8. This started out as 0 and it changed to 11,828. If it helps, put comments in here. All right? Total number of hours. Total number of minutes. Total number of seconds. All right? And I'll just put this one, it'll look a lot like the other one, but I'm going to put in total number of seconds inputted. Now, the program does not run any better when you put in comments. Did you hear what I said? In fact, it runs worse. Because the compiler, the thing that has to take what you type in and convert it into something the computer can understand, goes through and it removes all the white space in your program and all the comments in your program because it doesn't need them. So it can actually slow it down. But especially when you're learning, comments are a fantastic thing. All right? And I may have said this the other day, I don't remember, but a good litmus test is, do I need a comment there? If you have to ask, it's not a bad place for a comment. Period. All right. So here I'm inputting. So input total number of seconds. Now that's a little bit, you really probably don't need that because I've already got that right there. So you could argue and say you don't need that. But I'm asking you, is it possible? Let's say that I'm writing this program and later somebody else is going to come and they're going to end up maintaining it. You with me? Because that happens in real life. It does. Isn't it possible that somebody could come in later and actually add a bunch of code in here? I mean, I don't know. I'm not saying they ever will, but they could. All right. So now I'm telling exactly what's going to happen. All right. So I'm going to put a comment here that says validate total seconds inputted. I'll put it over 2 lines. Must be between 1 and 86,400. All right. So if I get into here, what? Input was invalid. Make user re-enter. Learn to spell, but you get the idea. Now, again, I'm going a little nuts here with comments, but I do want you to understand what's going on in here. That's why I'm doing it. All right? So when we get out to this point, now I can take this line, this comment line, and move it up. We have entered a number between 1 and 86,400. So what am I doing here? I'm printing out that number, right? That's all I'm doing. I'm printing out that number. Okay? Now I'm going to come in and I'm going to calculate all this stuff. All right? Let's see. Hours. This is 3,600. Yeah, we need that. But we're never using, please look up on the screen here, kind of an important, would you agree as this is gray and it's underlined, we're never using this? See this? We're never using that line in our program. Since we're not using it, you know what would be a good thing to do? Get rid of it. If it's gray, it means the program is not at least currently using it.
The variables,
they're not grayed out. It may look like it, but that's not the same color. All right? But the same kind of way, if you look, Christian, if you look up here, this is gray, this is gray, this is gray, and this is gray. So we could let the system come in and say, hey, remove all the ones we don't need. Boom. Some people like to leave those in there. Some people remove them. All right? But the one that I just removed, to me, that was, what's the word, superfluous? It was unneeded. And what happens when you put in code that you don't need and you don't remove it, it's known as code bloat. You're adding stuff to it that's not necessary. It does nothing to help the program. All right? So we came in and we did this. Now we validated. We did that. We have entered a number that's within range. So we calculate the hours. We calculate the minutes. And actually, what are we doing here? We're calculating the minutes and the seconds, right? Because we know that's what's left. And then here, not that we really need this, but output calculated hours, minutes, and seconds. Okay? I do want you to understand something. And we're going to actually add one more thing to this. And you might go, why are we doing that? I'm going to show you in a minute. But, okay, if I run this program again, one thing that's not really great about this program, I don't know if you agree with this or not, I want to run it twice. I want to run it the first time, and I want to know, I'm going to put in 4444 just to find out how much there are. Okay, so 4444. Okay, that's an hour, 14 minutes and 4 seconds. Do you agree with that? Okay, I want to run it again. And just for the heck of it, I'm going to put in 8765. Okay, that's 2 hours. Did you notice I had to run it twice? I don't want to run it twice. I had to run the program twice. All right? I wanted to give me my answer and ask me if I want to do it again. Well, no, because after I type it in and hit enter, it's already calculated it. So, but what I can do, guess what? You actually know how to do this. We used a while loop before, correct? We used a while loop? Well, I'm going to show you a bad example, and we'll clean it up in a bit. But what I can do is I can take all of the code that I've got, everything that's right here, everything, except that read line at the end. So everything that's here. Okay? So all of this stuff right up to here. I want that to run, and then I want it to run again, and then I want it to run again. Okay? So I'm going to take all of that code, and I'm going to put it into a while loop. So I'm going to say while, and this is going to look weird, but I'm going to say while 1 equal 1. And again, you might look at that and go, what? That doesn't make any sense. 1 is always equal to 1. I know that. Now I'm going to take everything that I had inside of here, and I'm going to tab it over. All right. So watch what happens now. I'm going to save this. We'll go back and look at it in a minute. All right. All right. Please enter number of seconds. Okay. 3, 4, 5, 6. Okay. There it is. Do it again. 2, 2, 2, 2. Do it again. See what we've done? Now we can run the program again and again and again. We do have a problem though. Now the only way we can stop the program from running is to go over here and click the X. All right. Plus the other thing I probably should have done is right here I probably should have put in a \n. So there's at least a line between each program run. I just put a \n in here before please enter number of seconds. So watch the difference. 1, 2, 3, 4. See that? Now it looks a little nicer. All right, 4, 5, 6, 7, etc. All right. So I can do that, but what I have done with this, would you agree that's always true? Would everybody agree with that? That's always true. I have created what's called an infinite loop. So the only way I can break out is to manually break out by putting in clicking that X. Well, I don't want to do that. Okay? I want to ask the user, do you want to run the program again? And if the user says yes, I want to run the program again. And if the user doesn't say yes, I don't want to run the program again. Does that make sense? So I'm going to ask the user a question, and the question is going to be yes, meaning it's true, I want to run the program again. Or I'm going to ask the user a question, and the answer is going to be no, meaning I don't want to run the program again. You remember what a true-false variable is called? It's a Boolean. So we're going to make another variable up here. And for lack of better words, it's a bool. That's what they use here. We're just going to call it again. And we'll set it equal to true, meaning we want to run this variable, program continue variable. All right, now we're going to change this to again. Now, if I run the program right now, if I run it right this second, I'm going to have the same problem. Because again is always true. Did you hear what I said? All right. Well, I'm going to ask the user, do you want to run the program again? Okay, we're just going to ask them that. And believe it or not, you know how to do that because that's kind of like this, isn't it? We're going to ask them a question. All right. Now, again is a Boolean variable. Did you hear me? Again is a Boolean variable, but that's going to just be true or false. If we give the user a message that says, enter a Y to continue, anything else to end the program, that Y is not a Boolean variable. That Y is going to end up being a string. I can tell you to put in a Y. You might type in yes anyway. You might do that. All right. So I'm going to add another variable here that's going to be of type string, and I'm going to call it first character, and I'm going to set it equal to nothing. And I'm going to just say first character input. Input it is fine. All right. So right now I've got the underlines there. All right. I've got the underlines there because I'm not using the variable yet. So we've just run the program. We just ran it. We're down to the bottom. Okay. So now we're going to ask user if they want to run program again. All right. So we're going to put in here a write. And we're going to say run program again. And then, I don't know, that's something simple like enter a Y or a Y to run again. Okay? Something like that. Maybe that's not the best thing, and there's better ways of doing it that we'll learn later. All right? So I'm going to say first char equals read line. Okay? That's going to grab whatever we enter into there. So we're going to come in here, we're going to say if that first character that they just entered, if either it's equal to a Y, or that first character is equal to a little y, okay? And there's plenty of different ways of writing what I'm showing you right now. I'm trying to be the most straightforward that I can. So I'm going to say, why did you mean, oh, it's going to be double quotes. All right. First char, whoopsie doopsie. First char equals true. I'm sorry, not first char. Again equals true. Else again equals false. All right. Now, before I do anything, let me run it, make sure it works. So I run the program. Okay. Enter number of seconds. 1, 2, 3, 4, 5. And it comes back and it says, boom. 3 hours, 25 minutes, 45 seconds. Do I want to run the program again? Enter a Y or a Y. Let's not enter that. So I'm just going to put in an N. Program's done. That looks good. Let's do it one more time. Do I run it? We'll run it again. Y for yes. And it's asking me to run it again. All right. And again. I'll put all that code up here so you can see everything. From the hard copy that I just gave you, what's changed? We added these two variables. A Boolean variable called again, and a string variable called first char, which means the first character. All right. Now look at this. This might look funny. While again, that's actually a shortcut that most programmers use. This is the same as while again equal true. It's just a shortcut. That's it. And believe it or not, you've written a fairly sophisticated program. All right. Still, even with that and all the comments, now we're up to 75 lines. It's not a long program, but it's sophisticated in that we're using constants, we're using integer variables, Boolean variables, string variables, a while loop, another while loop, input validation, all right, and an if statement that has an else. All right. So again, I can print this. I should have waited and printed it out now. But let's take a break. It was a lot later than I thought it was going to be. It's 9:07. Let's come back. I'm going to give you 18 minutes. At 9:25, we're going to come back and we're going to rewrite this. We're going to rewrite it as a GUI app. Yeah. And it's going to change because with GUI apps don't understand. They don't understand this. They don't understand that. I don't know if you agree with this or not. Right now, you're under control of the program. You have to follow the program's rules. When you have a GUI app, the program's under your control. That's the big difference between them. All right, so come back, please, at 9:25.